Good day everyone, it's me again, James C. Baclan, and today we will be dismantling this wall fan and identify some of its parts and its functions. So let's start now. Let's begin with the external parts of this fan. First part is this cord. Connect this or plug this in an outlet, then you'll have power for this to be able to function. Then next part here is the selector, wherein you can select from 0 to 3, 0 as off, 1 as the lowest speed of the rotation of the fan blades, then 2 as the medium, and 3 as the highest. Then the next one is the cover. This one, the cover. Let's try to dismantle the cover. This is full of dirt actually. So here are the cover. This one. Then the pair of this cover is this one. Then the next part, here are the fan blades. So our fan actually has 2 sets of blades. This one, the white one, and the blue one. Here. After this video, I might clean this. Then the other parts. Here, this one is actually up. There's a pin, a long pin, wherein you can pull and push this pin, but sad to say, it's broken. That's why it's stuck there inside, and we can't pull this anymore. And yeah, we'll go through the internal parts of it, and let's try to dismantle this fan. Wait. Oh, yeah, look how dirty this, guys. See that? I think it's the first time that's in the game. My god, this one's so dirty. Oops. These two covers the motor at the same time. Yeah, the motor and the other parts of the fan. The same parts of the fan. These two. So now, as you can see, it's so dirty, full of dirt everywhere. So about this part, there is not the other parts. Screws. I'm just moving the screws at the back. The next thing I'm gonna point out is 4-bar mechanism here. Let's see how that works. Wait guys, I'm here. Just think of 4 parts. Imagine a rectangle with not equal sides. Like it's like a rectangle but not having equal sides. So this is our first bar, the white one, this short one. Then the other bar is this one, this curved, somewhat like curved metal here. Then the other bar is the motor itself, this one. Then the last bar here is this one. The distance between this one here. This is the other bar. So it's very important to know that 4-bar mechanism, because you will be able to understand why the fan rotates in a certain angle and not in a 360-degree angle, or like not in a very small angle. Like it oscillates in a certain angle from this point to this point, then from this point to this point. So it depends upon how this 4-bar mechanism is set up. Here we have the crank. This is the ones that moving. This one, you have the crank. Then this one, the curved one, and the motor are the followers, the two bars are followers, then the fixed one is the fixed bar. When you have different measurements for that, guys, you'll have different kinds of rotation of that 4-bar mechanism, like different measurements and different positioning of the fixed bar, the crank, and the followers will give you different types of oscillation. So that's it for that 4-bar mechanism. And how does that move? So that 4-bar mechanism is connected to a gear, this gear here, which is also the gear is connected to the motor or to the rotor of the motor. This one, inside this one, this is the crank. This is connected to the other gear, this one. This is the gear. And this gear is also connected to the motor. Once the rotor rotates or spins, there is a movement that will be created between this gearbox and this 4-bar mechanism. So when the rotor rotates, the gear here will be triggered. Then once it's triggered, it will also trigger the gear here, making this fan to move, or like that, move like that, just like that, like that. Then as you can notice, fans have this pull pin here wherein you can make it steady or moving. So how does that happen? So it happens because when the fan is on, the rotor rotates, then the rotor here, inside here, the back of the rotor, there's a cold part of it, which is, let's say, a worm. It's like this, and that worm is connected to the gear here, this part here, this gear, which is called the worm gear. Let's name that the worm gear. So that worm gear and the worm is connected, and the other gear here, the last gear, this gear is connected to the crank. That's making it move. So if you decide to make it unsteady, you just pull this pin. When you pull this pin, the worm gear and this gear here connected to the crank will be disconnected, just like this. When you pull the pin, bang, so it's not connected anymore, so it won't make it moving. So this will become steady. But once you push that pin again, bang, push that pin, bang, it's connected. The worm gear and the gear connected to the crank will be connected again. Turn on the fan, then it creates a mechanism making it connected. Therefore, this one will also move. So the crank will also move, making the fan to oscillate. So that's how the steady and the oscillating of the fan works. So let's go through the inner part of the fan, which is the motor. The motor is also composed of capacitor here. This one, this is the capacitor of the motor. Let's try to clean that one. So there's a certain measurement of that capacitor, and it states here that it's 1.5 microfarad and 350 volts, 50 over 60 hertz, then negative 25 approximately to 60 degrees Celsius. That's the capacity of it. Then the other part of the motor is the thermal fuse. Let's try to locate where's the thermal fuse. It's so dirty. Where's the thermal fuse of it? Wait, guys. Let's try to dismantle more parts of it. I don't know if I can turn this back again. I'll be dead if I'm not able to. Since this is a functional fan, our only fan here. Oh my god. Again. And never love this way again. Patay. So here it is, guys. The capacitor are the thermal fuse. Where is the thermal fuse here? I think this is, my god, it's losing. Oh, it can't be dismantled. It's connected by tie wires. So just here, guys. I think the thermal fuse is inside here, and it's really hard to disassemble it. Here inside here, there's a thermal fuse. That thermal fuse is very important, since when the fan overheats, then it will interrupt the connection, making it like the circuit of this fan is disconnected. So that's why some fans, when the thermal fuse is destroyed, it won't function, and that's the common problem of it, overheating. Then the overheating is caused by dirt here, like too much dirt accumulated of the motor. Like when this dirt here gets more and more, then it might cause the fan to overheat, then making the fuse to, I think, explode. So that's why the connection of this one will be disconnected, not making this fan not to function anymore. Then here, the capacitor, this one also, when the fan starts to rotate slowly, like here, this starts to rotate slowly, or it's having a hard start, then try to check if the capacitor is still functional, or you might need to change this. And once you change that, the fan will begin to function again well. So that's the common problem of it, the capacitor and the fuse. Then now let's go deeper to the heart of the fan. So this is the most important part of the fan, the motor itself. Because guys, I disassemble the motor. You can obviously see now the coil windings, the commutator here, then the rotor, the fan here, this one. Ooh. The fan, this is the worm that I was talking a while ago, that's connected to the worm gear. Then the worm gear is connected to the other gear, which is also connected to the crank, which causes the fan to oscillate. Here, I think that would be it, and I still couldn't see where's the thermal fuse. I think it's this one, it's full of dirt. This one, this black here inside. now. So how does this work? As you can see, there's a lot of coil windings here. The motion or the force being created of this rotation is called torque. Then more coil windings produces more torque or more force. Then other thing is that how is this constructed? So it's just bunch of coils, magnets, stator, then you have commutator, and then the rotor, and the brush inside. I think it's inside, and I really can't disassemble it more because I'm afraid the wires might get cut too. How does an electric motor works? An electric motor works basically because of these main parts: the stator, the commutator, the brush, the armature, having the loops. It's important to know that having many loops ensures a continuous movement of current. So why is that? Imagine in a stator. The stator are the magnets having north and the south pole. Then for example, you only have one loop or one magnet inside. Then once it creates a rotation, it only creates a single rotation. Unlike having many loops, you create many rotations, continuous rotations. And to keep that moving or to have that continuous rotation, you need to have a commutator. And that commutator is connected to the armature, having the loops. Then that commutator is also connected to a brush, wherein that brush keeps the connection. I just can't really see where are the brushes here, but that brush, for example this one, this is the commutator. That brush, this one, the first brush, the second brush, this is connected to the commutator, and that brushes are connected to the circuit. And it's make sure that these brushes are connected to the commutator to keep that connection. So once that commutator rotates here, this is really a good illustration for a commutator. Once that commutator rotates, then here you have it's on, the current is flowing. Then here there's no current here. Then another rotation, current again, no current, current again, current for this loop, another current for this loop. So it's really continuously rotating. Like it's really having a constant production of or flow of current. Like once it's keep on rotating, then the brush is connected to that, rotates, connected to that, and this commutator is connected to the windings, and that windings is connected and that windings or that armature is having an interaction between the stator. There's a mechanism created between those parts that's keeping it to move. So that's how the motor works. And the next thing we should do is to put this back again, and it would be better if this is still gonna function, and I don't know if it will still function. So let's try to put this back on. And before that, let's have a recap. What are the parts again? This one is the worm I was talking a while ago, the fan, the rotor. These are the coverings of the fan, the capacitor of it, the capacitor. Then this is the pin that's making it steady or to oscillate. The gear, there's a gear inside this part here, there's a gear there. Then the 4-bar mechanism I was talking about here, the one I disconnected it already. This white, small white here, the motor itself. So let's try to put this back on again. And we're back at it again, guys. Wait, let's try to hang this one. Let's try to turn this on. Thank you guys for watching. See you on the next video.